In this video, we're going to talk about line segments, which we basically get by creating lines and restricting the domain so that we just get a part of it. So let's say I wanted to find the line segment that went from P, 1, 3, negative 2, to Q, 2, 5, 1. Now notice I did specify a direction there because I said we want to go from P to Q. So that means the orientation has to be pointing in this direction. Okay. So I can take as my starting point, it would seem reasonable to choose P as my starting point. So I'm going to say R of T is, and then I just write the position vector for point P, which would be 1, 3, negative 2 written as a vector, plus T copies of I need my direction vector. Let's just use PQ. Now PQ would be 1, 2, 3. So T copies of 1, 2, 3. Now that gives me the line. If I want just the line segment, then I need to restrict the domain. So let's see, what time value put me at P? Well, that was at time 0. That was my starting point. And what time value puts me at Q? That would be 1. What's nice about using PQ as the direction vector is that if I'm at P and I add 1 copy of PQ to it, I'm going to be at point Q. Okay. So that gives me my line segment, but that restriction on the domain is part of it. Okay. Now, that's a standard way of giving a line segment. I want to just show you one other option that we could have. If I write R naught, let's just say I had the origin somewhere over here. I'm going to write R naught is the vector that points to my starting point, and R1 as the vector that points to my ending point for my line segment. So notice R1 would just be R of 1 in this case, because that's going to take me to Q. So I'm just writing my starting and ending points as vectors. But then I can say that PQ is the same as R1 minus R naught. Because remember, when I subtract vectors, we don't really talk about subtracting points, but I can subtract vectors, and I'm here subtracting the position vectors for the points P and Q. Okay. R1 minus R naught would be the vector that points from the tip of the one I'm subtracting, the tip of R naught is P, to the tip of the one I'm subtracting it from, and the tip of R1 is Q. So I can write my direction vector that way. Now if I do this, I'm basically saying that R of T, I'm just going to write the generic version here, is R naught plus T copies of my direction vector, R1 minus R naught. So it's just a slightly different way of saying things. It's still starting point plus T times direction vector. It's just now, instead of giving the direction vector component-wise, I'm writing it in terms of the position vector for my ending location minus the position vector for my starting location. And I can rearrange this formula a little bit. So I'm going to get R naught plus T copies of R1 minus T copies of R naught. Now if you notice, those two terms both contain an R naught. Okay, so if I wanted to, I could consolidate those terms. I'm going to just write that over here. So I would get R of T is equal to, it looks like for the R naughts, I have 1 minus T of them. Plus, for the R1s, I've got T of them. And of course, we've still got that restriction that T is between 0 and 1. Notice when T is 0, that kills off this term. I'm at 1 copy of R naught, I'm at my starting point. When T is 1, that kills off this term. I'm at 1 copy of R1, I'm at my ending point. So that's just another standard way that you'll often see line segments written. Now, let's suppose I wanted to reverse the orientation for my line segment. I think I'm going to work with this version of things. and I want to reverse the orientation. Well, there are several options. I think the simplest one is just to reverse the starting point and the direction vector. Instead of starting at point P, let's start at point Q. So R of t would be, now my starting point is the position vector for point Q. Let's see, what was Q again? Oh dear, I've forgotten that. P was 1, 3, negative 2. Q was what I get when I added one of these. So that would be 2, 5, 1. Right? Yes. Okay. So R of t would be 2, 5, 1 plus t copies of, now this would be QP. I'm going to use the vector that points in the opposite direction, which would just be negative 1, negative 2, negative 3. I think that's the simplest way. Oh, let's not forget to restrict the domain so that we get the line segment. I think that's the simplest way of reversing the orientation, but I want to remind you of another one. In general, if I have a parametric curve, and that could be described with parametric equations or with a single vector equation, if I want to reverse the orientation, I can replace t with the opposite of t. That will always reverse the orientation. But let's be very careful, okay? Now, I don't replace this t with the opposite of t. If I replaced every single t with the opposite of t, I'd just be giving a different name to my parameter. I replace the t on the right side in the formula for calculating r of t with the opposite of t. So if I did that, that would become 1, 3, negative 2 plus negative t times 1, 2, 3. But be very careful. If I just copy this, I'm going to get the wrong line segment. Because if what we had was starting at P and going to Q, okay, if I copy this but replace T with the opposite of T, at time 0 I'm here, but now I'm going in the opposite direction, I'm not going to get the appropriate line segment. I'm going to get what starts at P and goes away from Q instead of what starts at Q and goes to P. The problem is that I need to replace all of the T's on the right-hand side with the opposite of T. So I would have to say 0 is less than or equal to the opposite of T is less than or equal to 1. When I then solve for T, I'm dividing through by negative 1. So I'm going to get 0 is greater than or equal to t is greater than or equal to negative 1. So we're actually now working on the time interval from negative 1 to 0. That works because now with this new parameterization, when t is negative 1, I'm at p minus 1 copy of p. Oh, I'm sorry. I can get this. Okay, I'm sorry. I'm at P minus negative 1 copies of PQ. So plus PQ, I'm at Q. And of course, at time 0, I'm at P. So I can replace T with the opposite of T, but do be very careful. If you're doing that in something that had a restricted domain, the description of the restricted domain will change as well. Again, I think it's easier to just change to what your new starting point is and your new direction vector, but I wanted to show you both options.